Suppose that you've collected a set of data and you've graphed them as ordered pairs on a scatter plot, and what you want to know is what is the best linear function to fit this set of real-world data. Informally, the best fit line is the line that appears to come closest to all the data points. This may seem like a pretty obvious concept, but the problem is it's difficult to really fine-tune it visually, but just visually we can get very close. So let's take a look at a set of data. We have a column that has Y in it for years since 1970, and another column called E, which is the number of full and part-time dental employees in thousands. So in the years column, we have 0, 5, 10, 15, 20, 25, and 28. And corresponding to those numbers, we have 222, 331, 415, 480, 580, 644, and 666. So if we plot each one of those ordered pairs, we get a graph that looks something like this, that starts at the point 0 to 22, and we have scatter plots that are increasing up to the final point, which is 28, 666. So I've drawn a graph on here of a linear function, and if I were to ask you, is this the best line, you'd probably say no, that's nowhere close. It does come close to some points. In fact, there's a pair of points here that are close to the line, but none of the rest of these points at the beginning and the end even come close. So clearly this line has a negative slope, and the data is increasing, so we'd expect to have a line that has positive slope, so this isn't the best one. How about this line? This is a line that's increasing. It has a positive slope, so it might be a reasonable choice. But this line is too steep, but it's better than the previous one. This is the best fit line, and when you look at it, it goes very close to all of these different ordered pairs, and it's going to be in fact closer than any other line. When I say closer than any other line, you got to remember that that's subject to interpretation. In our case, closeness is measured in terms of the vertical distance from the line to the data points. So on my graph here, I've drawn these dotted blue lines. That's the vertical distance. The best line is the one where the sum of the vertical distances squared is as small as possible. So if I label each one of these vertical distances here, D1, D2, all the way up to D7, this particular line, when I take D1 squared and add it to D2 squared, all the way up to D7 squared, that's as small as it can possibly get on this particular line. So the line that minimizes the distance, D1 squared plus D2 squared all the way up to D7 squared, is called the linear regression line or the least squares line, and is considered to be the best fit line.